solve systems of equations in context. This is a really great way to see how solving and creating systems of equations can help us solve real situations.
Your school sells tickets for a concert. Student tickets are $7.50 and adult tickets are $10. If your school sells 208 tickets and makes $1,772.50, how many of each type of ticket did they sell? Woo! Okay, let's break this down. What are the two things we're talking about? Student tickets, adult tickets. Okay, normally I would just say S for students, but my S's look like 5s and then I get all in trouble. So I'm going to use T because students are terrific. So let T equal the number of student tickets sold and let A equal the number of adult tickets sold. So if we have two variables, we need two equations in order to solve. So in this situation, it's very common that we end up with a quantity equation and a cost equation. What do I mean by that? Well, 208 total tickets were sold. That's the quantity. And then the other piece is, what was the total cost? That $1,772.50. So let's do our quantity equation to start with. Number of student tickets plus number of adult tickets equals 208 total tickets sold. Next, how much was each student ticket? $7.50 per each student ticket plus $10 for each adult ticket, and the total collected was $1,772.50. Now we have our system of two equations. We get to choose how we want to solve it. I think I'm going to do substitution, and I could solve the first equation for the T or the A. I think I'll choose to solve for A and then substitute into the second equation. You can choose whichever method you like. Go ahead, finish this out, and then let's see if we get the same answer. Okay, you might have noticed on that, I did pull out the calculator. We just need to be very thoughtful about when we need the calculator. So this was an appropriate time, I would say. Now I know the number of student tickets, but I'm not done with the problem. How many adult tickets? Let's go ahead and finish up the problem. It looks like 85 adult tickets. Now we're given the problem in context, so it makes sense to answer the problem in context. The question was, how many of each type of ticket did they sell? So let's make sure and answer it in reference to that. I chose to say it, the school sold 123 student tickets and 85 adult tickets. So long as you had the same information, it's okay if it's worded different. Now take a look at the next one. Can you go ahead and identify the two variables that you're going to choose to represent this problem? I chose X and Y to represent our two variable quantities. So X is my number of small bags of candy and Y is the number of large bags of candy. Then we need to go ahead and write our equations. What we know is 9 bags of candy were purchased all together. So I know that X plus Y equals 9. And next, I know that $44 was spent. The small bags of candy cost $3.50, so $3.50x plus $6 per large bag of candy for a total of $44. And once again, we have a system of equations. Let's solve. So the way I solved it, I got that I have 4 bags of small candy, and then I need to solve for the other. Now, if you solved it a different way, you might have the large bags first and then find the small bags. So of course, 5 large bags. 5 large bags of candy and 4 small bags of candy were purchased. Okay, how about just set up that last one? See if you can go ahead, identify your variables, write the two equations, and we'll check back in. So this one has a slightly different setup. I used H for cost of hamburgers and F for cost per fry. But this time we're kind of given the totals for 2 different orders. So if we just read through that sentence, we kind of write the equation straight from the sentence. When it says 9 hamburgers, that's exactly what I'll start out with, 9H. And plus 2 large fries, so 2F. Was a total of $36.75. So look at that. We have the first equation written. The next one is going to be kind of another order total. Your friend bought 6 hamburgers and 3 large fries. So 6 hamburgers, 6H plus 3F equals $27. Now we took out tax for this problem. What do you think about this one? I wouldn't solve it with substitution now. Now I would use elimination, but it looks like we're going to have to multiply both equations by something to eliminate one of our variables. Well, you know that you can choose which one you want to do because it'll work so long as we don't make any little errors. But remember, we want to make one of them negative. I think I'm going to get rid of the fries, the F. So I'm going to multiply the top by 3 and the bottom by -2 so that one of them becomes negative. Be sure that one of the most common things is kind of forgetting to distribute it throughout the entire equation. So I'm going to make sure and write it maybe on both sides. Whatever you choose to do, just be very clear and very obvious. Make sure that you give yourself the best chance to not have errors. So now my new equations, we're going to multiply through. Let's see what you get. Okay, you'll see once again that I did pull out a calculator for this just to be a little bit careful. And now I have that hamburgers cost $3.75. Let's plug back into either equation, use one of the original equations, and find out how much fries are. Did you notice I chose the second equation to plug back into? I just thought the coefficients and the constant looked a little bit easier in the second equation. So always be thinking about it. It's never about first equation, second equation. It's like which is going to have the least amount of work, and therefore I can do more of it in my head and not even need that calculator. So we have fries are $1.50. Now finish up, write your answer in context of the problem. How did you write your final answer? Was it like I did? Did you make sure your dollar sign was in front? Did you make sure when you wrote $1.50, you didn't just put $1.5? That's not how we write money, right?